In this video, I am going to solve some problems for the topic magnetic coupled circuits. This is the problem number 1, finding equivalent inductance. This question is given in the year of 2000 only, but it is the basic, so we will solve this problem. So here, three inductances are connected in, coupled circuits are connected in series. Okay, we have to find the equivalent inductance between the terminals AB. So here dotted ends are given. So for L1 dotted end is given here. Current leaves at this dotted end, and here current enters at the dotted end, and here also current enters at the circuit 1 and 2, and here this is between coil 2 and 3, and this is between coil 1 and 3. So we can draw the circuit like this. So this is between A to B, L1, L2, L3, and here dot is given here and here. So we can represent this as M12 between first coil and second coil, and here M23 mutual inductance between second coil and third coil, and here M13. So we can write the equation. So here we can write the equation L equivalent equal to L1 plus L2 plus L3. So according to the mutual inductance, for the first coil and second coil, this is current leaves at the dotted end, and here current enters at the dotted end. So minus, it is subtractive in nature, so minus 2M12. And then between coil 2 and 3, here current enters at the dotted end, here also current enters at the dotted end. So same polarity. So plus 2 into M23. And here current enters at the dotted end, and here current leaves at the dotted end. So between coil 1 and 3, that is opposite polarity, subtractive in nature, so minus 2M13. So let me substitute the values. What are the values? L1 is 4 Henry plus 5 Henry plus 6 Henry minus 2 into 2 plus M23 is 2 into 3 plus, minus 2 into 1. So 4 plus 5, 9, 9 plus 6, 15, 15 minus 4, 11, 11 plus 6, 17, 17 minus 2, 15. So 15 Henry is the L equivalent for the given circuit. Okay. So let me solve the second problem. Here two identical coupled coils are connected in series. The measured inductances for two possible connections are two possible series connections. Here it is given. Two possible connections are 380 microhenry and 240 microhenry. The mutual inductances. They asked the mutual inductance. Here this question is given in the year of 2014. Okay. So what are the series connections? Series aiding and series opposing connections. So series aiding means additive connection. Additive connection, current enters. And series opposing, subtractive connection, current enters and current leaves at the dotted end. Okay, so L1, L2. So here for the additive connection, L equivalent will be equal to L1 plus L2 plus 2M. This is M. So plus 2M, that is given as 380 microhenry. And here for the subtractive connection, L1 plus L2 minus 2M, that is given as, for the subtractive connection, that is given as 240 microhenry. So now this is taken as first equation and this is taken as second equation. So 1 minus 2, this will get cancelled, and this will, we can sum this, and here this will be 240 plus 1 microhenry. So M equal to 140 by 4, that is equal to 35 microhenry. So answer is 35 microhenry. We found the mutual inductance for the given question. M is 35 microhenry. Okay. So this is the second problem. And let me solve this third problem. So this is also given in the year of 2005 something only, but it is an important problem here. The problem number 3 is two identical coils of negligible resistance when connected in series across a 200 volt 50 Hz source draw a current of 10 amps. When the terminals of one of the coils are reversed, then current drawn is 8 amps. The coefficient of coupling is, okay. So here they have given the current value, they asked the coefficient of coupling. So we know the current equation. What is the current equation? Normally, what are the connections first? Series aiding and series opposing connections. So we don't know the initial condition, whether it is series aiding or whether it is series opposing. Okay, so this is series aiding. So normally current equal to V by X for the AC networks. Okay, so X is the mutual reactance. Here it is a mutual reactance. A total reactance is, so for the series opposing, let me take this as I1. This is I1 and this is I2. Okay, so for the series opposing connection, I1 equal to V by omega into L1 plus L2 minus 2M, and I2 equal to V by omega into L1 plus L2 plus 2M. Okay, so here if the denominator has the lesser value, the current value will be greater. So here see here, so first series connection draws a current of 10 amps, and when the terminals are reversed, then current drawn is 8 amps. So 10 amps is greater than 8 amps. So we can find this series opposing is the first connection. After this condition, the connection is reversed. Okay, so that is series opposing is the first connection, series aiding is the second connection. So we have taken correct only. I1 is the current for the series opposing connection, I2 is the current for the series aiding connection. So I1 we can take it as 10 amps, I2 we can take it as 8 amps. Okay, let me solve the problem. So here 10 equal to V is given as 200 volt by omega into L1 equal to L2, because two identical coils. So we can substitute L1 equal to L2. So 2L minus 2M. So this can be taken as first equation. And second equation, I2 is given the value as 8 amps. 8 amps equal to 200 by omega into, here also L1 and L2 is equal. So 2L plus 2M. Okay. So this is taken as second equation. Now first equation divided by second equation means this 200 will get cancelled, omega will get cancelled. So 10 by 8 equal to 8 equal to 2L plus 2M by 2L minus 2M. So rearranging this equation, this will become 20L minus 20M, that is equal to 16L plus 16M. Okay, so 4L equal to 36M. So M equal to 1 by 9L. 1 by 9L. Okay, relationship between mutual inductance and self-inductance. So here M equal to 1 by 9L. What they asked, the coefficient of coupling. So we know the equation for coefficient of coupling, K equal to M by root of L1 L2. So here M we found as 1 by 9L, and here already L1 L2 are identical, so root of L square. So this will get cancelled. So coefficient of coupling we found as K equal to 1 by 9. That's the answer. Thank you.